Well, to wrap up the class and to kind of talk about the very, very last material for this, we're going to go into Chapter 7, and we're actually going to go a little further into Chapter 7 and start with 7.3, 7.4, and then go into 7.6. What we're doing in 7.3 and 7.4 is specifically learning how to count the number of ways that a specific task can be done. Like, let's say, for example, you're going to go to Las Vegas and you want to know, okay, out of that deck of cards, how many potential cards in there could I get? If I want to get a 5-card hand, how many ways can I get a specifically, let's say, a full house? Or how many ways can I get just 2 of a kind? Or just 3 of a kind? And so what Chapter 7 is all about is learning how to count. And then after you learn how to count, we throw those techniques into a term called probability, which y'all have all heard of probability before. And so if we start here in section, at the very, very top of this section here with 7.3, the very, very first, most foundational thing in counting principles is this multiplication principle. And what the multiplication principle is all about is saying that if you want to try to decide how many ways a task can be done, let's say how many different 5-card hands are possible in a deck of cards, or how many ways, like we're going to go here to example 1, how many different ways outcomes can happen when I flip a coin, things like that. Well, the way to figure out how a task can be done, how many different ways, is you want to multiply together the number of ways each of its subtasks are performed. Okay, so you're thinking subtask, task, what's going on here? Let's just dive into example 1 and hopefully it'll make a little bit more sense. Here in example 1, you're taking a coin, okay, just a normal coin, heads and tails, and you're going to toss it 4 times. And the sequence of heads and tails is going to be recorded. So that's the main task, is this recording of these heads and tails as I flip this coin. What we want to know is how many different outcomes are possible. Okay, well, think about it. If you're going to flip a coin 4 times, one potential outcome could be getting all heads, like heads on the first, second, third, and fourth flips. Or how about all tails? Or what if we alternate heads, tails, heads, tails? That's just 3 potential outcomes right there. So how many total outcomes are there? Well, what I do is I'm breaking this down. There's technically 4 subtasks. A subtask being the first flip, the second flip, the third flip, and the fourth flip. So what we need to do is isolate and just focus on, okay, in one flip itself, when I take a coin and I flip it, how many outcomes are possible? Well, there's just 2. There's the head or the tail. All right, now I'm going to leave that one. Let's go into the second subtask where I'm going to flip the coin a second time. Well, again, when I flip it the second time, really the first flip has no effect on it. There's still 2 possible outcomes, a head or a tail. The same thing with the third and then with the fourth flip. So what this multiplication principle is all about is saying if you want to know the total number of ways a large task can be done, this task being flipping a coin 4 times, then what we do is we multiply together each of its subparts or its subtasks. So then there are 16 total outcomes. Over here on the right, I just listed out 3. These are just 3 of the 16. Okay. Other ones could be, tail heads, or heads, heads, tails, tails, or tails, tails, heads, heads. You're kind of getting the idea. But if I listed all these out, there would be technically 16 total outcomes. And again, the most important thing is when you get each subtask, flipping a coin the first time, the second time, the third, and the fourth, you don't add up those possibles, you multiply them. It's all about the multiplication principle. So keep that in mind. It's like when in doubt, multiply. So let's go to example 2. A mouse is challenged to go through a maze. The mouse must first pass through one of 2 doors, then one of 4 doors, and finally one of 3 doors before coming to the finish. How many ways can the mouse go through this maze? Okay, well, one way can be going through always the first doors of everything. Comes to a pairing, goes to the first door. Then comes another one, first door, first door. So that's a possible. Or it could be first door, then second door, then back to first door. Or first, then second, and third door. There's lots of going on here. So let's think about this. Basically, the mouse is going to go through one of 2 doors. So it's like, let's say the mouse starts here. It's got an option. Here's one of 2 doors. And then it's going to go to one of 4 doors. And then it finally ends up with one of 3 doors that they can choose from. Well, let's think. What's going on here? There are 3 possible scenarios the mouse is coming to. The first scenario is the one of two doors it can choose from. So it has two options when it comes to the first block. Now it gets through one of those doors and it goes to the next set. Well, how many options are for that next set? Well, there are 4 total doors they can choose from. It gets through, it picks one of those and then goes to the third set. In that third set, there are 3 possible doors that mouse can choose from. So a grand total of how many different ways it can go through this, we're going to go 2 times 4 times 3 and get 24 total options, or total door options, put it that way. Okay, 2 options when it comes to the first dilemma, 4 options for the second dilemma, and 3 options for the third dilemma. And a grand total, so like I said, one of those potential 24 ways could have been picking door 1 every single time, or door 2 every single time, or door 1, then door 2, then door 3. You know, it kind of changes every option. All right, let's keep going on. Let's go to example 3. This is one of my favorite ones. I kind of made this one up, but as you think about it, it's kind of funny. Your friend always complains that she has nothing to wear. Okay, that's always happens, right? But when you look in her closet, she has 3 pairs of shoes that will match any one of her 6 jeans and 12 t-shirts. So how many outfits can be made from just these alone? Okay, the big task is forming an outfit. Each of the subtasks is picking a shoe, a pant, and a t-shirt. Okay, so the big task is a big outfit, and we have 3 parts to it. Okay. The first part is picking a pair of shoes. Well, how many options do we have for the pair of shoes? 3. The next one's pairing a pair of pants or the pair of jeans. Well, there's 6 options there. And then the third thing is picking a shirt, so there's 12. So all of these, one of the 3 pairs of shoes, one of the 6 pairs of jeans, and one of the 12 shirts is going to form a full outfit. So when we multiply these together, we'll get a grand total of 216 total outfits. Alright, so when you think to yourself, does this person need to go shopping? No. I mean, granted, you don't want exactly wear the same, jeans with the same t-shirt and all you're doing is changing out your shoes, because that'd be kind of weird. But saying, look, right there, 260 total outfits, and all you had was 3 pairs of shoes, and we all know we have more than 3 pairs of shoes, 6 jeans, and 12 shirts. So it's kind of a little funny. You might go home and just test that on, if you're a guy, test that on your girlfriend and see what's going on with that one. All right, so let's go on. Let's go to example number 4. Okay, here in example 4, you're looking at an exam. An exam has 5 true-false questions followed by 10 multiple choice questions. How many ways can this test be answered? So the big task is figuring out how many ways can a test be answered. So we got to go to all the different subtasks. Well, the subtasks are these individual questions from the test. Well, we've got 5 questions followed by 10 questions. So 1, 2, 6, 7, 8, 9, 10. There we go. There's all my questions right there. Well, let's go down the line. For this very first question, which is going to be a true-false one, the first of the 5, let's see, 1, 2, 3, 4, 5. Put a little break in there. For the first 5, there are just true-false questions. Well, how many options do you have with true-false? Just 2, a true or a false. So we have 2 options for the first question, the second, third, fourth, and fifth. Okay, because the first 5 questions are only true-false questions. It's like a head or a tail. You're going to get a head or a tail. You're going to get a true or a false. Now the next 10 questions, though, are multiple choice questions, and they each have 4 options. So we have 4, 4, and y'all are kind of getting the idea here, because what we're finding out is it doesn't matter if you answered A on the first multiple choice question, you can still get an A on the second one. We don't know. It could be all A's for the multiple choice part. Okay, so together then, the total number of ways the test can be answered, so the total number of ways to answer the test is multiplying all these together. So 2 to the 5th times 4 to the 10th. And I'm just going to leave it like that. Can you think, just think about it. How many different outcomes is that possible of just answering? And this is just a 15, it's just a 15 question test. It's crazy. Just plugging this in my calculator really quick. 1, 2, 3. Got to count here decimals. It looks like it's 33,554,432. That's how many ways that as a professor that we could have potential answers when all I have is a 15-question test. The first 5 being true, false, and the next group being multiple choice. Kind of crazy, isn't it? But it's amazing how many things add up fast. And truthfully, that's why when you go to Vegas and you're like, are the odds of you really winning that great? Not so much. Because look, that's just coming out of a 15-question test. It's kind of crazy. And if there's only... So what are the odds that you get everything perfect? It's one out of 33 million of you getting everything correct on that test. So when you get 100 on a test, pat yourself on the back. That did a pretty good job. So you had a 1 out of 33.5 million chance of getting that test perfectly correct. All right, so let's go on to example 5.